Hi everyone, I am Yogesh Pandey. I have total 11 years of teaching experience and I am MSc B.Ed. I am presently pursuing a postgraduate diploma in school leadership and management. Today we are going to start with the new topic, that is polarization of light. We know that light waves are transverse waves. Now according to Huygens wave theory, light travels from one place to another in the form of waves. Waves are of two types, that is longitudinal waves and transverse waves. In a longitudinal waves, the vibrations of the particles of the mediums take place in the direction of the propagation of the wave, whereas in transverse wave, the particles of the particles of the medium, the vibrations of the particles of the medium are perpendicular to the direction of the propagation of the wave. Sound waves are longitudinal waves. Huygens had initially assumed in the wave theory that the light waves in ether are also longitudinal. He explained many phenomena like reflection, refraction, interference and diffraction of light from his theory. But in 1690, when Huygens himself discovered the phenomena of polarization, he had to discard the idea of assuming light waves as longitudinal because it could not explain polarization. After nearly 140 years, Fresnel proved that light waves are not longitudinal but they are transverse waves. Now transverse wave means the light waves can travel in vacuum without requiring any material medium, whereas longitudinal waves, example is sound waves, and they can they cannot travel in vacuum because they require a material medium. Now we have an experiment here. The transverse nature of a wave can be tested by a simple mechanical experiment. Let a horizontal string passing through vertical slits in figure, this is the given figure. So cut in cardboard pieces be held by two persons A and B in their hands. Let the person A moves his hands up and down parallel to the slit. This gives rise to transverse waves in the string. The particle of the string vibrating parallel to the slit S1. These are the two slits, that is S1 and S2, and these are the two cardboards. So we have to pass a string over here. So there is a person who is standing near A and is doing up and down with the string. So this gives rise to the transverse waves, because the transverse wave direction is like this. The vibrations are like this, up and down, and these are perpendicular to the direction of the propagation of the wave, and that's why surface of the water waves is one example of the transverse waves. Now if the slit S2 is parallel to the slit S1, the vibrations pass through S2 and reach the person who is at the B, and reach the person with undiminished amplitude. So the amplitude undiminished means the amplitude will remain constant, it will remain uniform. The amplitude will remain uniform. Now what is the amplitude? Amplitude means the maximum displacement from the mean position. So this dotted line which is there, here we can write here mean position, and this is the amplitude over here from here to here. So there is one peak and there is one valley. So this is the amplitude, and which is going undiminished, and it is reaching to the person at B. Now if however S2 is rotated to become perpendicular to S1, the vibrations are stopped. The vibrations are stopped by S2, as the displacement of particles is now at right angles to the length of S2. The string therefore does not vibrate beyond S2. Now you can see in the diagram, the string cannot vibrate beyond S2 because now it is perpendicular here. In the second slit we have kept it perpendicular over here, and the S1 the string therefore does not vibrate beyond S2. In the intermediate positions of the slit S2, the vibrations are partly transmitted and partly stopped. That is, they reach the person B with diminished amplitude. Thus, we conclude that as the slit S2 is rotated, the amplitude of the vibrations varies. Now, in the first case, we have seen that the vibrations, they are reaching here with the undiminished amplitude because both the slits are parallel. But in the second case, the slit S2 is perpendicular to the slit S1. So when S2 is rotated we are seeing that the vibrations are also changing, they are also varying. This variation in amplitude is due to the vibrations in the string being transverse. Had the vibrations been longitudinal, that is parallel to the length of the string, they would have passed through the slit S2 in all angular positions of S2. This means that had the vibrations been longitudinal, so suppose if they are longitudinal, that is parallel to the length of the string, they would have passed through the slit S2 in all angular positions of S2. For example, sound waves, if they were sound waves, then they would have passed in all the angular positions through the slit S2. Thus, we conclude that if the amplitude of wave produced in a string passing through slits S1 and S2 varies when S2 is rotated, then the wave passing through S1 is transverse. If on the other hand the amplitude remains same, the wave is longitudinal. So from amplitude we can say that if the amplitude is varying, so the second case, the waves which are entering, the vibrations which are entering in the slit S1, they are transverse, and if we are getting at the B, we are getting the unchanged or undiminished amplitude, or the amplitude remains uniform. So we can say that the vibrations which are entering at the slit S1, it is longitudinal wave. Now let us see the next topic, that is experimental demonstration of the transverse nature of light.